Hello, welcome to everyone to today's event, International GCSE Chemistry Exam Insights from the May-June exam papers 2024. We're going to look at some papers from the June exams. We're going to concentrate on paper 1C and 2C, start with an overview of each paper. We will then consider some candidate strengths and weaknesses before we get into the detailed analysis of the different question types on papers C1 and C2, where we will discuss candidate performances. So firstly, looking at an overview of papers 1C and 2C. Paper 1C was an accessible paper with candidates performing well overall. The multiple choice questions prompted candidates and were generally well answered, with candidates able to recall well. Constructing chemical formulae, even with a multiple choice prompt, was yet again challenging for candidates. The first question on each paper is usually the most accessible. However, question 1A, despite being multiple choice, was answered poorly. This was a combination of misconceptions and possibly skim reading the question. The extended response questions proved to be the most difficult area of the paper, with candidates usually able to score some but not all of the marks available. Candidates would do well to practice planning and structuring their answers to ensure all marking points have been covered. The calculations were well answered, and those who made minor errors were still able to get error carried forward marks. Questions around practical techniques were once again challenging to candidates. The strengths of paper 1. Candidates performed well in questions relating to the reactivity series, as in question number 2. Candidates were able to successfully interpret chromatograms, as in question 5A, 2. Overview of paper 2C. Paper 2C introduced a new format with a two-curve graph question and some previously untested content, as in question 7B. Candidates struggled with 3-mark explanation responses, as they did in paper 1C. Practical-based questions and writing chemical formulae also proved challenging to candidates. Many candidates lost marks drawing the energy level diagram through not using a ruler and lack of precision when drawing arrows. The strengths of paper 2 were that many candidates were able to gain full marks in the graph question. Many candidates did well in the calculations and also in the short answer questions. So let's move on to look at a detailed analysis of the questions. We're going to be looking at these grouped by question type. Firstly on paper 1, and then the same question type on paper 2. So starting with multiple choice questions, on paper 1, question 1A was on choosing some substances from the box provided to fit the description as requested. Candidates should be advised to read the question carefully to understand that they can use the substances more than once. They should also underline key information in the description, for example, element, liquid, and room temperature. This first question on the paper was worth 5 marks. And the first question is usually aimed at easing candidates into the paper and ensuring they have a good chance to answer correctly in order to set them up positively for the rest of the paper. But unfortunately, many candidates only scored 3 marks on this question. As just mentioned, they didn't read the question carefully enough, and also particularly the instruction, which said each substance may be used more than once, or once or not at all. Looking at some of the responses and how they answered, water was the common incorrect answer given for a good conductor of electricity in the first row. Other comments on this question were that water was also a common incorrect answer for the second row because candidates overlooked the question was asking for an element. Candidates who selected lithium in the first response did then not use it again in the fourth response because they didn't realise or hadn't read carefully enough that they could use a substance more than once. Methane was given as a common incorrect answer for the substance which forms the polymer in the last row of the table. The third row of the table. Methane was commonly chosen without realizing that the suffix was an alkane and therefore would not be able to form a polymer. An alkene was needed for this answer. Question 7D1, another multiple choice question where they're being asked to choose the correct formula for ammonium carbonate. The candidates would do well to recall and annotate the charges of ammonium and carbonate ions around the question to help them answer the question. They could then use these formulae to work out the correct answer, and then they can choose the option which fits. Looking at the choices here, A is incorrect because the overall charge would be positive and the formula for the ammonium ion is incorrect. B is an incorrect answer because the formula for the ammonium ion is NH4 plus, not NH3. C is incorrect, as although the formula for the ammonium ion has been written correctly, the compound would be negative because of the balance of the carbonate charge. So D is the correct answer. This is the chemically correct formula. 2 ammonium ions are needed to balance the charge on the carbonate ion. Short response questions in paper 1. Question 1B, where candidates were asked to describe a test for chlorine. Candidates who read the question carefully generally scored 2 marks for this item. Some candidates did not answer the question carefully, and they wrote out the test for chloride ions instead. Some candidates hedged their bets by describing the tests for chlorine gas, and they also gave the tests for chloride ions. So they lost out on the marks because of the list principle. They had given 2 answers, 1 correct, 1 incorrect. Minor errors such as red litmus turning blue and then bleaching were often seen, and also blue litmus turning red, and these cost candidates marks. Some candidates recognised that it was a test for a gas, but unfortunately they described tests for incorrect gases, such as hydrogen or oxygen, by using splints. Question number 2 on paper 1, where information was given about metals and their reactions with water and acids or lack of reaction. And this information was then had to be used in following parts of the questions, such as A part 3, where a word equation was asked for between aluminium and hydrochloric acid. Candidates often attempted to write a symbol equation instead of giving a word equation. Water was commonly given as an incorrect product. Candidates who ran out of space occasionally wrote their second product on the left-hand side of the equation underneath the reactants, and as such, they lost out on credit. The candidates who wrote correctly balanced chemical equations were given credit, but often they were unable to balance the equation correctly. Question 2A part 4, they needed to name a metal which could be metal P from the original table. And here they needed to apply their understanding of the reactions of metals with water and the reaction or lack of with acids, plus the position of metals in the reactivity series. P had been listed in the question as having no reaction with water or with acids. Therefore, it was a low reactivity metal which they needed to answer. They needed to give a metal which was less reactive than hydrogen so that it would not react with an acid. And correct answers could have been gold or silver or platinum or perhaps copper, all of which we would have scored. But most candidates chose unsuitable metals, such as a non-metal or potassium, which is highly reactive, or even iron, which is above hydrogen in the reactivity series and therefore not suitable. Question 2B part 3 was asking about the reaction between aluminium and iron oxide, and they were asked to say why that this was a redox reaction. Very few candidates scored full marks on this question, which was disappointing. The candidates who scored 1 mark were correctly able to identify that the aluminium was oxidized because it gained oxygen. The most common incorrect answer, however, was that iron loses oxygen. And since the question was involving aluminium with iron oxide, it was the iron oxide which loses the oxygen. Or they could have written the formula Fe2O3. Therefore, iron oxide was reduced, Fe2O3 is reduced, not iron alone. This was a very common answer. Candidates who attempted to talk about loss of electrons made similar mistakes, as they said that Fe or iron gained electrons rather than the iron 3 plus iron gained electrons. Question number 3. This question was about element Z. Just give you a moment to have a read through the question in case you're not familiar with it. This question was answered very well. Those who lost marks mainly lost some marks in B, where instead of multiplying the 6 times 10 to the 23 by 12, they divided instead. Question 5 was on chromatography, where the before and after chromatograms were displayed. There were 2 parts to this first section of the question, A1 and A2, both of which ask for an explanation, and the command word explain requires a statement followed by justification. Most candidates managed to get both marks on these 2-part questions. On to the next part of the question, however, 5A part 3, candidates generally scored only 1 or 0 marks out of the 2 available here. Most were able to identify that F was insoluble or did not move. However, candidates tended to state that they could be certain about G, but they were not able to give an explanation for or a justification for why they could be certain. In order to score that mark, they should have explained that they could only be certain about G because it only had one spot on the chromatogram after developing. Moving on to question 6A2, this question was relating to a solution of sodium hydroxide which had been made. And they were asked to explain the colour of the indicator after it had been added. And candidates generally answered quite well, but many of them were unable to actually give the correct colour for the indicator for phenolphthalein. Candidates would do well to learn the colour changes of different indicators. Question 6B. This was about a flame test and why the wire needed to be cleaned. Candidates were generally able to score M1 for identifying that impurities needed to be removed. And there are many ways they could say this, which is why OWTTE or words to that effect could be used instead. Many ways to explain that. But fewer candidates were able to score M2 for stating that the impurities might mask the flame colour or cover up the flame colour. Potentially also the impurities might give a different colour. Question 7C1, where candidates were asked to write the chemical equation. Looking at the question, they were actually prompted what was reacting and that there was one product, nitric acid. And candidates struggled badly with this question, as they did with other chemical equations they were asked to write on the papers. Candidates would benefit from using the white space around the question to work out the correct formulae before they try to put them into the equation. The most common error was being unable to recall the formula of nitric acid, or perhaps just making a mistake in that formula. Candidates should read the question very carefully and not add in any additional products to the equation. The candidates who were able to recall the correct formulae for all of the reactants and products were generally able to balance the equation correctly, and therefore they also scored an additional mark, gaining 2 overall. Question 8A2. If you look at the bottom half of the screen, you can see the question displayed there. The question gave the displayed formula of one of the isomers of the alkene, but1-ene. And candidates were asked to draw the displayed formula for 2 other alkene isomers with the same molecular formula, C4H8. They understood what was being asked of them, but there were very many common errors in the answers, and we'll be looking at those shortly. So to summarise the main errors, firstly, candidates redrew the same molecule, but with a bend in the carbon chain, or a different orientation, perhaps flipped over or upside down. There were errors in the bonding of the carbon atoms. Some candidates mistakenly added extra bonds to the carbon atoms. It was quite common to see a carbon atom with 5 bonds, and also potentially with 3, but 5 was the most common error. They were being asked to draw another alkene, and the structures drawn commonly lacked a double bond at all. There were also cycloalkane structures drawn, and although these are isomers with the same molecular formula, they are not alkenes as they were requested to do. So now we're going to have a look on the next slide at some questions, some responses which candidates produced. So firstly, I'll give you a few seconds to look at those two and see how their errors relate to the previous comments about common errors. So looking at these diagrams drawn by the candidates, the diagram on the left lacked a double bond, and also they have not got 4 bonds to the carbon atoms. The diagram on the right, although a correct molecular formula there, it's not an alkene, it's a cycloalkane. Another response from a different candidate was this pair of suggested isomers. The diagram on the left is still the original butene structure. It's simply been drawn backwards. Therefore, it didn't score. The diagram on the right, although it shows a double bond and it has a branch in the carbon chain, the central carbon atom has 5 bonds, and the carbon atom below the central carbon has only got 3. So yet again, this candidate scored 0 for their answers. A third candidate produced this pair of isomers. Now you've had time to look at them, I'm sure you'll realise that the one on the left-hand structure, is butene, redrawn with a bend in the carbon chain. The molecule on the right-hand side, the candidate has put the double bond between the second and the third carbon atom, but unfortunately, the carbon on the left of the double bond has got 5 bonds, and the carbon on the right has only got 3. If one hydrogen had been drawn on each of those 2 carbon atoms, they would have arrived at the correct structure of butene as being a possible isomer. So there were many, many errors in answering question 8A2. Moving on to 8C, candidates were asked to draw the repeat unit of polypropene. Again, unfortunately, there were many errors with this question. There were unbranched chains being shown, which had 3 trailing bonds. There were also answers which contained double bonds. The structure shown on the left of the screen is what the mark scheme was looking for. The CH3 did not need to be displayed, or it could be drawn in its condensed form. This correct answer was very rarely seen. Question 8E1, candidates were asked to balance this equation and also supply the state symbols. The majority of candidates were able to balance this equation correctly. However, problems came with the state symbols, with completing in the state symbols. In particular, G was a common incorrect answer for carbon instead of an S. And water was also incorrectly marked. It was commonly written as AQ for its state symbol, when it should have had an L as it's a pure liquid. Question 9A1 and 2, where they were being asked about why the balance lost mass, showed a loss in mass. These 2 marks, parts of the question, were actually marked independently. The candidates struggled to answer these two questions correctly. They were contradicting their answers. However, because they were marked independently, the candidates were not penalised for that. Many candidates correctly stated that the mass decreased due to either carbon dioxide or a gas being lost. However, they then lost that mark because they identified the gas as being hydrogen or oxygen or even water vapour, which was an incorrect statement. The equation did provide the information that the gas was carbon dioxide, and they'd failed to use that. Candidates did struggle to express the purpose of the cotton wool. Many who gave the correct answer for part 1 went on to say that the cotton wool was to stop the gas escaping, rather than the acid spray or any liquid from the flask. Question 10A, where the students were given a list of the practical details that were happening in the method. And yet again, they were asked to complete a chemical equation for the reaction. Candidates need more practice with writing chemical equations. We've seen already today several parts of the paper where there have been problems with chemical equations. They need to learn general equations for reactions of acids and metals. Here they were not supplied with the products. The general equation is metal plus acid gives a salt plus hydrogen, and if candidates had learnt that, it would have made it much easier for them to come up with the correct answers required here. Because if they didn't know that it was magnesium nitrate with hydrogen, then unfortunately that is another mark lost. Question 7C1, where candidates were required to take a reading off the thermometer and complete the table. The instruction in the question said give the temperatures to the nearest 0.1 degrees C. Candidates often read the thermometer correctly, but they lost a mark by writing 16 degrees instead of 16.0. They missed the instruction to give the temperature to the nearest 0.1 degrees C. 7D1. Why is the polystyrene cup going to give a more accurate result? Most candidates were able to gain M1 for identifying polystyrene being an insulator, but M2 was less often scored because candidates did not write comparative statements. The best answers included those who stated that less heat would be lost by using polystyrene. So moving on to paper 2 and looking at the short response questions in this paper, question 1B asked them to compare the reactivity of sodium with lithium. Candidates struggled with some key terms in this question, and as a consequence, they lost marks. Most were able to appreciate that sodium has more shells of electrons. However, some lost marks by excluding a mention of the outer shell, or they said outer shells, plural. Candidates talked about increased number of shells and the ease of losing the electron, but they did not mention that there is a weaker attraction of the outer electron to the nucleus in the larger atom. Some candidates showed an understanding of outer shell electron loss, but they did not apply their knowledge of group 1 having only one outer shell electron. and shielding was rarely seen as part of the response, again causing marks to be lost. Question 2B was about the sacrificial protection in the rusting of iron. Candidates did not appreciate that this was not a barrier method. They should be prompted to consider previous questions. As the barrier protection method was included in 2A2, it will not gain credit in 2B. Most candidates were able to show an understanding to score M2. The more reactive metal will react or oxidize more readily. M1 was rarely scored. Despite demonstrating good understanding, candidates did not link the process of coating or connecting the more reactive metal to the iron. A common answer was to use the more reactive metal than iron, but without it coating the iron or connecting to it, then the answer would not have scored. M1 and M2 were marked independently, which allowed candidates to score 1 mark usually. Question 3B2 about fractional distillation of crude oil. Many candidates lost marks here for silly errors such as using the incorrect terms or missing out parts of the question. Most appreciated that the crude oil needed to be heated or vaporized, but many lost the marks as they stated that this happened in the fractionating column. Many candidates combined M1 and M2 by saying that crude oil vapor is passed into the column. Some candidates did not express M2 very well, and they just referenced the column, but without the vapor passing or into it or rising. Candidates commonly lost M3 as they did not mention kerosene or they did not explicitly state that it left the column. Candidates should be reminded not to repeat the stem of the question. For example, crude oil is heated and goes into the column where kerosene is obtained. M3 does not score. It is just repeating the question. Question 3C2. Why is cracking useful? This question was poorly answered overall. Candidates showed some understanding of the topic, but they did not express themselves well, thus missing out on marks. Candidates gave parts of, but not complete answers to all of the marking points. Candidates included the terms supply and demand, but they did not explain or identify which fraction was which. Candidates often stated that alkenes were produced, but not what they were used for. They often stated that smaller hydrocarbons were made, but like the alkenes, they did not state a purpose for these smaller hydrocarbons. Question 5A1. Two characteristics of an homologous series. This question was answered very well, and candidates have spent time learning the characteristics as many varied responses were seen. Minor errors often seen were that they all had the same chemical reactions instead of similar, that they all had the same molecular formula instead of that they differed by CH2. 5B Part 3. Draw the displayed formula of methanol and methanoic acid. And this was generally answered very well. The candidates who lost marks often did because of the fact that they didn't display the OH bond. They wrote OH instead of O bond H. Question 6A. This question was either answered very well and scored all 3 marks for the production of the precipitate, or they made two common errors. They missed out on M2 because they didn't wash the precipitate, or they got confused and rinsed the filtrate instead, which was the solution. Many candidates gave descriptions of crystallization in their method, so they were dealing with heating the filtrate instead of concentrating on the solid. Therefore, they only scored M1 on the question. Some candidates lost M3 for saying that they needed to dry the solid, but they didn't give a drying method, such as blotting it with filter paper or leaving it to dry in the air. 6C Part 1. Electrolysis. Why does the lead bromide need to be molten? Candidates made the same common errors here and the same omissions with this question. Most failed to describe the ions as being fixed in the lattice or fixed when they were solid in fixed positions. Whilst candidates were able to state that ions can move when molten, they did not further explain or state that they needed to carry a charge. So they lost M3. Most candidates did manage to score M2 by saying that the ions were not free to move in the solid. Question 6, C3, D1 and D2. Just take a brief look at the question, as you may not have seen the various sections before. Questions about half equations are common, and candidates would do well to memorize general half equations for positive and negative electrodes, which they can then apply to the context of the question by balancing. Question 7a, which was asking for a definition of a covalent bond. This is another common exam question, which candidates who had learnt the definitions were able to answer well. Most scored 1 mark by showing that an understanding of a shared pair of electrons being involved in the bond. And those candidates who did not score a 2nd mark did not explicitly state that it was an attraction to the nuclei of the two atoms involved, or they only talked about one nucleus attracting that pair of electrons. So now we're going to move on to look at calculations, which were in paper 1 and in paper 2. We'll look at paper 1 first. Question 3C gave information about element Z. And students were asked to calculate the relative atomic mass and give an answer to 1 decimal place. So now we'll have a look at the breakdown of how they did on this question. Many candidates were able to score all 4 marks, and those who did not tended to make the same errors. They missed the prompt to give the answer to 1 decimal place. Candidates used the atomic number, which was in the table, instead of working out the mass number and using that for each isotope. These were the most common incorrect answers which were seen. For A Part 1, here they needed to calculate the formula mass of caffeine. And overall, this calculation was done very well. 5A Part 3, relating to the chromatography question we looked at earlier, where the RF value needed to be calculated. Candidates were able to score some, but not all of the marks on this question. They needed to measure accurately from the baseline to the center of the spot. And also they needed to measure accurately from the baseline to the solvent front. Many candidates inverted their calculation to get 1.67, and they failed to realize that RF values should always be less than 1, and they do need to be reminded of that. Some candidates did their measurements correctly, and they calculated the RF value, but then they went on to multiply this value by 10 or even 100, and that caused them to lose marks. Question 6C2. Here they needed to calculate the value of X, the number of moles of water of crystallization in the formula of the double salt. A large number of candidates were able to score full marks in this question, which was very encouraging. The candidates who struggled were usually able to get 1 or 2 marks because they were able to calculate the mass of water for 1 mark and the moles of either the salt or the water to gain a second. Some candidates were able to score the first 3 marks, but they lacked the understanding to get the correct ratio for X, and therefore, unfortunately, they lost M4. Some candidates can feel overwhelmed by questions such as this, but they should still always attempt to do some part of the calculation and score at least 1 mark, or if they make an error in their calculation, that they should be available to get error carried forward. So they should always be encouraged to attempt the calculations. This is a very common exam question, and candidates need to focus on learning the steps in order to be able to calculate the values independently. Looking at the breakdown of the steps, step 1 was to calculate the mass of the water. Step 2, to calculate the moles of the anhydrous salt. Step 3, to calculate the moles of water. And then step 4, to calculate the ratio, dividing the answer to step 3 by step 2, arriving at the answer of 12 for X. If candidates were aware of the steps and have learnt the steps in advance, they have a much better chance of applying them in an unfamiliar question on the day of the exam. Question 8D. They have to calculate the values of X, Y, and Z. This question proved challenging to many candidates. 2 marks were commonly scored where candidates were able to get Y and Z. Candidates would benefit from using the white space available on the question paper and around the equation to try and do some working out. The most common incorrect answers were to get X being 19 or 28, and then unfortunately forgetting that oxygen O2 is diatomic. The best candidates set out their working to this question in steps. Once the candidate had calculated Y as 9 and Z as 10, they then wrote down the ratio of the oxygen, added up the number of oxygen atoms as being 28, divided by 2 because it's diatomic, arriving at X is 14. Question 10C1 and 2. These are enthalpy calculations, and in the second part, in C part 2, they need to give an answer to two significant figures, and they are prompted to include a sign in the answer. Looking first of all at how candidates performed on 10C1, most scored both marks in C1. Common errors were to use the temperature rise of 16 degrees instead of 16.4. In 10C2, the candidates need to be reminded to practice calculating out the steps. They were able to use their previous answer from C1, or they could round it to 2,800. They were generally able to calculate the moles of magnesium and also able to convert between joules and kilojoules. But they lost marks often where they didn't give an answer to two significant figures, or they forgot to include a sign. It can be very useful to get them to remember to go back and reread the question before they move on, especially with a calculation, and then they could pick up on errors such as that. So if we look at the calculations on paper 2, this was a question which had not been asked in this way before. Candidates needed to plot two sets of data and interpolate and extrapolate information. Most candidates identified the temperature to be the point at which the lines crossed, i.e. approximately 67 degrees C. Candidates generally performed well, and many were able to achieve all 10 marks on question 4. Some candidates mistakenly wrote down 75 degrees C, which was the temperature at which the lines finished. Question 4D. Candidates were prompted here to show they're working on their graph, and that if that is the case, they must show it. Those who didn't were only able to score M3 because they did a correct subtraction. Question 6B, 1 and 2. Most candidates scored all of the marks. Those who didn't had usually not shown their working in B1. Question 7C. Here, candidates needed to do a calculation and then draw the enthalpy profile diagram. If we look at C1 first, most candidates were able to score all 3 marks on this part of the question. Those who didn't tended to confuse their signs and give the answer as plus 184. Some candidates were unable to use the equation to help, either assuming they had to double the bond energy of the reactants or forgetting to double the bond energy of the products. Looking at 7C2, drawing the enthalpy diagram, candidates struggled to score all of the marks in this question. Many marks were lost unnecessarily by failing to draw their arrows correctly. That they were often drawn too long or too short, or they had no arrowheads on them. As well as this, many failed to label the reactants and the products, or they got the formulae or the balancing incorrect. The equation had been given in the question, so they should have transferred that over. Some candidates missed the activation energy hump, and this limited them to 2 marks, and they could not score M1 and M4. A reminder to candidates, using a pencil and a ruler will allow them to make a mistake and then erase it. And they also do need to have precision when they're drawing the arrows. They were, however, able to score error carried forward if they had an incorrect answer from C1. So here are some exemplar answers. You won't have seen these before because they were not taken from the examiner's report. This candidate has got some parts of the question correct. They drew a good diagram, but they wrote HCl on the product side when it should have been 2 HCl, so that lost them 1 of the 4 marks available. Another new exemplar. Take a quick view of this question. This question was a good diagram and it scored all 4 marks. Reactors and product formulae are correct and correctly balanced. The activation energy hump is there and EA is correctly drawn in with the arrow pointing in the right direction. Similarly, the enthalpy change is correct. And another one. Now this one lacks the energy hump, and so that limited them to a maximum of 2 marks. So moving on to the extended response questions, which we said earlier proved challenging to candidates. If we start with paper 1 and look at question 4C, where they were asked to explain why calcium bromide had a much higher melting point than caffeine. This question was worth 5 marks in total. So a candidate who didn't perform very well on this potentially was losing a significant number of marks. It was challenging, as often looking at the evidence for bonding and properties can prove to candidates. With any extended response question, candidates are advised to plan their answer and perhaps annotate the table to help them structure their response. In step 1, good candidates linked the melting point and the energy required to break the bonds. Caffeine had a low melting point, so less energy was needed. Calcium bromide was much higher, more energy was needed. And then they could link that to the type of structure and the bonding. So the good candidates were able to link these requirements and identify caffeine as being a simple molecular structure and calcium bromide as being ionic. There were many common incorrect responses and misconceptions. Candidates did not give the structure of either or both of the substance. For example, saying that calcium bromide contains ionic bonds does not specify that it is a giant ionic lattice. Candidates stated that calcium bromide contained intermolecular forces and that they can only exist between molecules, not in an ionic compound. Or they stated that there were ionic bonds between atoms instead of between ions. And candidates often mistook the energy required to melt caffeine by saying that it broke strong covalent bonds, when in fact it's a low energy requirement because it's breaking weak intermolecular forces. So we're going to have a look here at some candidate responses. Just briefly have a quick read of that, since you've not seen this before. It's very important that candidates read the question carefully. This is candidate A's response, and it scored all 5 marks because it covered the bonding, type of structure, and it compared the energy requirements of both compounds correctly. Now we're going to have a look at candidate B. And candidate B lost marks because they included irrelevant information and they misidentified that calcium bromide, saying that it was covalent instead of ionic. We'll just have a brief read of that. The key to doing well on extended response questions is to read the question very carefully, plan what they want to say, and then try to express it clearly. It was a 5-mark question, so potentially 4 or 5 marks could be available to them, and they shouldn't be answering it too quickly. Question 7D2. This question was asking for tests on the ammonium ions and the carbonate ions. Candidates struggled most with the tests for the ammonium ions and giving the correct result. They often confused ammonium ions with ammonia gas, and the candidates who gave the correct test for ammonium ions often forgot to specify that it was the gas which was being tested. Most candidates were able to describe the test for the carbonate ions correctly. Those who didn't score added extra reagents into the test when adding the hydrochloric acid, such as barium compounds. And some candidates lost M5 and M6 by not explicitly stating that the gas was being tested with lime water. So we look at some exemplar responses. Again, these are new ones you won't have seen before. Candidates who scored the best marks broke their answer down into sections and/or used bullet points. Candidates should not be afraid to plan their answer. They can write in sections, they can use bullet points. This way they can ensure that they have covered all of the requirements of the question, even them ticking them off. And as suggested before, rereading the question before moving on. This candidate scored all 6 marks. And we look at another response, which also scored 6 marks. You can see it's been put in numbered points in 2 sections, clearly explained. Extended response questions on paper 2, some examples here. A question about the colour of litmus paper when in hydrogen chloride dissolved in water versus an organic solvent. Candidates showed understanding of the topic and content, but they were unable to apply their ideas correctly. The litmus bleaching white was a very common incorrect answer. And as shown in paper 1C responses, candidates need to learn the distinction between chlorine gas and chloride ions. On the rare occasion that candidates linked hydrogen ions turning the litmus red, they often negated this afterwards with saying that it was bleached. This question was heavily structured to allow candidates to identify the ionization, but still they struggled. Candidates thought the litmus would turn an array of colours. Many different ones were seen: red, green, and the common white for bleaching in the organic solvent. They also thought that it would be alkaline. Other candidates thought the key aspect was the litmus being damp, and that was causing the colour change. The water was causing the colour change, and not the hydrogen ions. This is, again, another new exemplar answer, which you can see a candidate has written. This candidate scored all 4 marks because it's fully correct. However, in comparison, this candidate scored only 2, unfortunately. They've gained M1 for saying that the litmus paper stays blue, and it does not dissociate in the organic solvent. But in M3, they have stated that the litmus was bleached. Potentially, they might have scored in M4 because they started to mention hydrogen ions. But M4, as you'll see from the mark scheme, is dependent on scoring M3 by saying that the litmus turned red, and they didn't do that. So this candidate was limited to 2 marks. Practicing these type of responses in class is a good teaching tool to try to get candidates to spot errors and then perhaps improve their future answers. Here is another response written by a candidate for this question. This candidate scored 0. They've mixed up the 2 solutions, and this was a common error. If the candidate had written the first part about the organic solvent and the second about the water, it would, however, have still scored 0. The reason for that is that they wouldn't get M1 because they said there was no reaction. They didn't say no colour change, they said no reaction. M3 would not have been scored because they have put in the do not award the bleaching of the paper. And yet another response here, which also scored 0. This candidate has stated that the HCl does not dissociate, although they phrased it as stays intact. It would turn red because it's acidic in the organic solvent, and unfortunately that is incorrect. They also think an alkali is formed in the water. So these were very common incorrect answers. Another one here, again scoring 0. As previously, the candidate stated that the HCl in the organic solvent was acidic and the litmus turned red, and thinks again that there are hydroxide ions to make the litmus stay blue because it's alkaline. So in summary, paper 1C, the principal examiner in their report said that candidates should ensure they have provided enough detail in extended response answers to secure maximum marks. They should not be afraid to use bullet points to help check they aren't repeating themselves and to set out their work clearly. They should learn chemical tests carefully. They should practice interpreting graphs and explaining what the results show. They need to consider gradient and endpoints of curves when they draw graphs. They should consider the terminology they are choosing when writing their answers. The principal examiner for paper 2 suggested that candidates should read the question carefully. Clues in the question were often missed. Learn standard definitions which are frequently assessed. Avoid repeating the stem of the question as this is not credit-worthy. They need to plot points carefully. They will all be checked. They need to draw a smooth curve of best fit, which is not feathered or a dot-to-dot line. They should show working on the graph when asked to extrapolate information and show all working in questions that request that to be done, otherwise marks will be lost. Support from Pearson for you as teachers. The Access to Scripts service is a free online portal which allows teachers to immediately access electronically marked exam papers. It provides enhanced transparency and offers transparent approach to the marking process. Will provide better understanding of marking before you might want to make requests for inquiries about results. It will provide an excellent aid for teaching and preparing other cohorts for examinations by helping you to evaluate a student's performance on particular questions in relation to what they have been taught. It's available instantly from results day for all of our examination series for a defined window. You can view and download scripts which have been marked online free of charge from our self-service portal. For more information on the post-results windows, visit our post-results pages. We also have Results Plus available to you. This is a free online results analysis tool for teachers. It provides a detailed breakdown of student performance in Pearson Edexcel exams. You can identify topics and questions where the student could benefit from further learning and inform teaching strategies and approaches. You can benchmark your school's performance against other Pearson Edexcel schools in your country. It's not just a post-results tool. Mock exam results could also be fed into the system to produce a similar analysis. You can find student results analysis from their previous Pearson Edexcel school. Results Plus Direct gives your students access to their final grades and performance breakdown wherever they are. Schools can sign up for a free Results Plus account in just a few quick and easy steps using the following link. We also have Exam Wizard, which is available to you. This is a free tool for teachers which helps you to make quick homework assignments and topic tests and mock exams. Questions are tagged against unique topic and assessment objectives, or simply you can choose a whole past paper. You can use existing mark schemes for accurate marking. You can use the examiner reports for insight. And the most recent exam content will be available sooner to you. You can use the results to understand where students need more support and use that to inform your teaching strategies. You can find out more about professional development courses from Pearson's Professional Development Academy. If you have any further questions, then please consult the subject advisor, which you can find on the Pearson website. Tim Lawrence is the IGCSE Chemistry and Science subject advisor. And the details, a telephone number and link are available for you to apply there. Thank you for your attendance today, and I hope that you have found the session useful.